Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 3rd, 2025, just yesterday, and this paper introduces a brand new way to test how multimodal large language models compare pairs of videos. It proposes the video difference captioning task and a 1,000 pair benchmark that exposes a big gap in how current models describe similarities versus differences across time. The paper is titled ViDiC, Video Difference Captioning. And as we will see later, the evaluation setup has some clever twists that really stress test motion understanding and edit awareness. Figure 1 lays out what it actually means to compare two videos in this benchmark, and how the automatic scoring works. The top grids show paired clips for 7 kinds of changes, like subject, motion, camera angle, and playback technique, which means tricks such as reversing or speeding the clip. In the middle left, the background change example highlights how a caption should mention both shared context and precise visual edits. On the right, the dashed panel illustrates checklist questions, where a judge model marks each statement about the caption as correct or incorrect. At the bottom, the icons summarize the pipeline, from the 2 input videos, through caption generation, to automatic checklist-based evaluation. Figure 4 shows what kinds of videos and annotations the benchmark actually contains, so we understand what models are being tested on. The big wheel on the left breaks content into subjects, actions, scenarios, and shooting perspectives, which reveals broad coverage from daily tasks to commercials. The top middle plot illustrates how many checklist items each video pair gets, with most pairs having only a few fine-grained questions. Below that, the donut charts summarize clip durations and resolutions, while the flow diagram on the right traces how many pairs come from each source dataset. Table 1 compares this new benchmark with previous datasets that look at visual differences. The upper rows list older image-based benchmarks and one video action differencing set, which mostly use reference-based scores that match captions against fixed ground truth sentences. The last row highlights ViDiC 1K, which mixes real and synthetic video, covers 35 change categories, and uses checklist plus language model judging. That combination makes the test broader in scope and more focused on factual correctness. So while Table 1 contrasted benchmarks, Table 2 shows how specific models actually score on this video difference task, revealing a clear ranking. The closed source block at the top achieves the highest average accuracy, which means these systems both avoid hallucinations and catch more real edits. The open source block below performs slightly worse overall, yet some larger models come surprisingly close. The right side of the table breaks results into categories like camera and playback technique, highlighting that even the best models struggle most with these temporal and editing cues. The light bulb superscripts mark thinking modes, which encourage longer reasoning and boost difference detection, but also introduce extra hallucinated differences. Figure 5 highlights where different multimodal models are strong and where they still fall short in describing video differences. The top left radar chart compares overall accuracy across 7 major aspects like subject, motion, camera, and playback technique. The remaining 7 charts unpack this into fine-grained skills, such as reading text on screen, sensing camera shots, or detecting video reversal tricks. Qwen 2.5V L72B Instruct generally leads, yet all models remain weak on camera, motion, and playback technique cues, especially things like fast versus slow or reversed playback. Alright, to wrap up, ViDiC shows that describing what changes between two videos is a much harder and more revealing test than just captioning a single clip, and current multimodal models especially struggle with motion and editing cues. That gap opens a new frontier for training and evaluation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.